This video discusses how to use the sample scripts to capture data via the FOS RESTConf API, generate reports, and perform a node find across multiple fabrics. The legal disclaimer is here for you to read. Comments, questions, and feedback are always appreciated, and I'm available for consulting. Follow the GitHub link at the bottom of this page for a copy of this presentation and scripts described herein. The last section of the Getting Started video discusses common features and inputs for the sample scripts. Let's talk about capturing data first. Typically, data is captured with the multi-capture script, which is discussed later in this video. Since multi-capture launches this script, a brief explanation of those inputs is required. In addition to the logging credentials and logging options discussed in the Getting Started video, this module also has the following scripts. The -F option is the output file for the captured data when launched from multi-capture. This is the folder project multi-capture created. -C, this is optional. By default, only data used for the report is captured. If you intend to use captured data for other scripts such as restore, consider using an asterisk. And when using an asterisk, the script will attempt to request data for everything FOS supports. Depending on the chassis type, some of those requests may not be supported. So you'll see some error messages. You can ignore them. Using this option with file names is outside the scope of this video. -fid, that's optional as well. By default, all logical switches are automatically determined, and data is captured for all of those logical switches. Using this option for a list of FIDs is outside the scope of this video as well. -CLR, that's stands for clear. It allows you to clear port statistics once all the port statistics have been captured. -NM, by default, only the last octet of an IP address is stored. When you set this option, you can store the full IP address. The intended use of these examples is to provide you with something that you can copy and paste and modify to your own use. Note that I'm using a / in the file name. / is interpreted as a parameter separator. If you want to use a / in the file name, it must be enclosed in quotes. As with this capture script, this script is typically launched from other scripts. Multi-capture is one of those scripts. The most common reason for using it as a standalone script is when you want to include captured data from another SAN that was not included in the original set of captured data. If you rerun this script, delete the combined data file first. -I, this is the folder, not an individual file. When launched from multi-capture, this is the project folder it created. -O, this is the name of the output file only. It is placed in the folder specified with the -I parameter. When launched from multi-capture, this file is named combined. Again, the intended use of these examples is to provide you with something you can copy and paste and modify for your own use. So multi-capture creates a timestamp folder for captured data reports, simultaneously launches capture for every chassis listed in the input workbook. It launches combine after all capture is complete. It then optionally launches something to generate reports. Other than performing some management functions to create the project folder and launch the other script, it doesn't do anything else. Typically, data is captured for full SAN or multiple SANs. My advice is to capture data from all switches in both the A and B fabrics, and at least occasionally all fabrics in your organization. It's not uncommon to have zone members in the wrong fabric, and you don't want the report to find all those for you. With the Windows PC and just 16 gig of memory, I was able to launch 200 instances of capture at the same time. That means I had 200 file handles open and 200 HTTP sessions open at once without issue. I didn't have 200 switches, so HTTP sessions were spoofed. My concern was that the number of open HTTP sessions might cause problems. I didn't have any issues. My conclusion of this test was that you're going to have to make a sales rep really happy to break it. Quick review of the inputs. -I, that's the name of the workbook with the login credentials. Since this module captures data from multiple chassis, it would be cumbersome to add all the login credentials via the command line. So all login credentials are read from an Excel workbook. Use the multi-capture example workbook from Brocade REST API applications as a template. This workbook is discussed in greater detail on the next slide. -F, that allows you to specify a project folder name. Use of this option is outside the scope of this video. By default, a timestamp folder is created. -R is optional. There's no parameters. When you specify that, it generates the report, the compare report, and the maps report by launching those appropriate scripts. -C, -CLR, and -NM, those are passed to capture. -BP, -sheet, -SFP, -group, and -IOCP are passed to the report script, which will be covered shortly. Capture was the one we just completed. So for the workbook example here, most of this is pretty self-explanatory. The security column does not default to self, so it must be explicitly stated. The name column is required, but it's only used for error reporting. For example, if the login fails, this name will appear in the error message. You should use a name that you could easily identify with the chassis, but any printable characters are supported. There is no limit as to how many rows you could use. Only the columns are read. As long as the header remains in row 1 and you don't reuse any of these header names, you could add whatever columns you want. It's common to add columns for physical location, other documentation. Columns are found by name, so the order of the column doesn't matter. The typical command, again, this is here for copy and paste. Now that we've captured some data, let's generate some reports. Nodefind is the most frequently used script I have. That's not surprising because nodefind is one of the most frequently used CLI commands. So differences are PIDs are not searched for. Reject and wildcard matching is supported. This is most valuable feature in here because I'm often looking for nodes that belong to a server cluster or a storage array. It finds multiple nodes simultaneously. Searching on zone names is supported. When you do that, it's the zone members, not the zone that the nodefind works on. Nodes are found on an entire project, not just a single project, and that's useful because I typically want to see both the A and the B fabric. And it works off of previously captured data, so there's no need for a live switch. And optionally, it generates an Excel workbook with defined results. And that's convenient because often when I'm doing a search on storage arrays or clusters, I also need to prepare a list of those ports for cable teams to work on. -I is the captured data file. When launched by multi-capture, it's the combined data file. -alias, that's an alias or CSV list of aliases to search for. The alias may contain rejects or wildcard characters. See the -S option discussed on the next slide. Note the warning with -alias regarding the use of quotes. This applies to world by name and zone as well. Regex text often contains characters that are interpreted as a parameter separator, so they need to be enclosed in quotes. In my opinion, the resulting error message when you don't do that is a bug in the parser library. I'm not writing my own custom argument parser, so I'm living with this. -alias_f, that's just another way to enter aliases. Sometimes it's easier to copy and paste a list of aliases into a file. So -WWN and -WWN_F, that's the same as alias and alias_F, but for worldwide names. Typically, worldwide names are only searched for LSAN zones. -zone, -zone_F, that's similar to alias and alias_F, but for zones. When using rejects or wildcards, the filter is applied to the zone name, not the zone members, but it's the zone members that are added to the list of nodes to search for. The script builds a list of nodes to search for, so you can use any combination of input parameters that define what nodes to look for. -S, this is the search type. It is applied to all of the inputs. The handout notes have some additional comments about what a wildcard and regex syntax should look like. -R, when specified, a report with a page similar to the login sheet produced by report is created. As with other examples, this is just here for your reference. I'm changing gears now to the report script. -I, -O, those should be pretty straightforward. The -B option is a name of a workbook used to define best practices. Alerts are generated for these violations. -sheet is the name of the worksheet in the workbook to use. If you're just getting started, try using standard rules with the sample best practice workbook and the Brocade REST API applications. Dash SFP, that's optional as well. It defines SFP thresholds to alert on in the report. If you're just getting started, set this to SFP _ rules _ R12, and that workbook is in the Brocade REST API applications as well. The dash group, I'm going to spend some more time talking about that on the slides to come. So my advice when creating this workbook is just copy the group's workbook that's included in the Brocade REST API applications and edit it to suit your needs. Again, there's an instructions worksheet with some details. So the first column to look at here is the group. Any length of printable characters is supported. If the same group name appears more than once, the group is added to. The filter column, this is usually alias. You could use WWNs, but typically those are only used for LSAN zones. Details on how to define a group with a WWN is in the instructions worksheet. Operand, this is what you're looking for. So in this example, I'm looking for aliases that begin with storage with 1 or 2 using a regex match search. And then that second line there, I have, again, I'm adding to storage group 1. And this time I'm going to add anything that matches storage _3 question mark doing a wildcard search. And the operator, that's just, how am I going to do the search? So regex matching, regex searching, wild, and of course exact is supported. And the comments, you can put whatever you want in that comment. This is an example of what the group workbook would look like in the report. To simplify the illustration, not all columns are shown. The group name and member is what's defined in the workbook. So that's right here. The next thing is the member. So this is the member that was found in that group. And then everything else is what is zoned to that member. So you can tell the difference between, well, first of all, they have a check mark in the left-hand column, and they're also bold, the actual members versus the members that were just found zoned to it. So that column there, that description column, is a hash of FBMI data and name server data. Typically, storage offers up some name server data, but I don't see anything in here. Typically, storage does not offer up FBMI data, but servers do. These two scripts are only worth a brief mention. They were created before SANNAV had this capability. At the time, Network Advisor was limited to 20 ports and did not collect statistics from many counters. Although not used much anymore, they are sometimes useful for troubleshooting when you don't know which ports to look at yet, or there is a need to capture more data than SANNAV is capable of capturing. Most people use Kafka screens from SANNAV to capture statistics. If you're looking for a way to capture statistics to add them to your own database via the API, look for stats _2 _db _app or stats _2 _db for some examples on how you could do that. And with that, thank you very much for watching.